Hi everyone, and welcome back to another episode of the We're Gonna Make It podcast show, the podcast where we dive deep into the latest in emerging tech. I'm your host Harshdeep, and today we're unraveling the enigma of deepfake technology. So buckle up, because in the next 15 minutes, we'll explore the fascinating and yet sometimes frightening world of AI-generated content that's blurring the lines between reality and fiction. Let's begin. Deepfakes, a combination of deep learning and fake, are hyper-realistic videos or images that depict people saying or doing things they never actually did. Picture this: a video of a world leader declaring war, but it's completely fabricated, created by algorithms that can mimic their face and voice with accuracy. That's the power and peril of deepfake technology. At its core, deepfakes are born from two phases: Phase A and Phase B. Think of an autoencoder, an AI algorithm that learns the features of Phase A and then transposes them onto Phase B, creating a composite that looks like B but is fundamentally altered. This isn't just cutting-edge tech talk, it's a process that's becoming increasingly accessible to anyone with a computer and an internet access today. But here's where it gets dark. Deepfakes have found a home in the black markets for creating illicit content. They've been used to impersonate business leaders, meddle in politics, and generate fake pornographic material, leading to devastating consequences for individuals' reputations and privacy. So how do these deepfakes come to life? They're crafted using deep neural networks called autoencoders. These networks encode an image or a video down to its essential feature, stripping away the unnecessary bits altogether. Then comes the decoder, which reconstructs the original from its distilled code. By training these autoencoders on a pair of real and fake videos or images, they learn to encode both types accurately, resulting in realistic-looking deepfake content. The tech behind is interesting, and it includes algorithms like 3D ResNet and 3D ResNext. These powerful tools can manipulate images and videos with such finesse that it becomes increasingly difficult for us to distinguish between what's real and what's not. Now, let's talk about detection, because as much as we're fascinated by creation of these things, we need to know how to spot a fake. Researchers are developing methods like deepfake network architecture attribution, which can trace back fake images to their generator architectures. It's like detective work for AI, attributing fakes to their digital origins. But here's the kicker. While some methods can extract distinct features from AI-generated images effectively, when they encounter novel or differently trained images, they start to falter. That means our ability to detect deepfakes has to evolve as quickly as the technology used to create them. Moving on to the tools of the trade for creating these digital doppelgangers. There's DeepSwap, which is user-friendly and quick as lightning in generating deepfakes. It's so efficient that it has become popular among those looking for a bit of recreational mischief online. But beware, once you're subscribed to this, it might take more than just a simple click to unsubscribe it. The next one is DeepFace Lab, which is not quite user-friendly but highly valued by students and researchers for its flexibility and compatibility with various machine learning technologies. It may not be as straightforward for everyday users, but for those with programming skills, it's a treasure trove. The next one is Deep Nostalgia, which brings old photos to life with animations so smooth they'll make you do a double take. And if you're looking for something more artistic, Deep Art Effects is your go-to application, though mobile users might find themselves grappling with a bit of compatibility issues on this one. So the options are quite a lot out there, you just have to figure it out. Moving on, I'd like to put a caveat here that with great power does come great responsibility. While these tools offer incredible capabilities for creativity and innovation, they also open up a Pandora's box of ethical dilemmas. As much as we marvel at the wizardry behind these AI-generated illusions, it's crucial to have our defenses up as well. So, talking about defenses, let's see how we can shield ourselves from these deepfake problems. Well, early on, spotting a deepfake was a bit like catching a magician in the act. You'd look for these glitches, slight discrepancies that gave away the trick. But times have changed today, And now we're in an era where deep learning is our Sherlock Holmes, which sifts through data, extracts those telltale signs, screaming absolutely fake. Think of deepfake detection as a binary classification problem. It's basically real versus manipulated. So it sounds simple enough until you realize that you need a trove of both genuine and counterfeit videos to train your models. And while fake videos are multiplying like rabbits today, there's a dire need for standardized benchmarks to test our detective tools. And to save the day enters datasets like face swap GAN's 620 video models, which are crafted using clips from publicly available movies and designed to mimic realistic facial expressions down to the last blink itself. These datasets are playgrounds where various detection techniques can strut their stuff or stumble and fall if they can't cut it. And here's another reality check. Some of our most trusted facial recognition systems are flunking the deepfake detection test. Even methods that scrutinize lip syncing and picture quality are coming up short today. The message is loud and clear. We need stronger shields against these digital shapeshifters. Now let's break down the arsenal we've got for detecting these fakes. First up is fake image detection, which uses convolutional neural networks or CNNs and generative adversarial networks or GANs that have upped the ante, making it harder for forensic models to spot swapped faces that perfectly match the original positions, the expressions, and even the lighting. One approach uses word-bag technique to pluck out the compact features from images and feeds them into the classifiers. But when it comes to GAN-synthesized images, boy, we are talking about a very tough cookie to crack here. It's very high quality and realistic enough to fool even the sharpest of eyes. The second one is video detection. Because videos compress frame data, image detection methods don't often make the cut here. Videos have this whole other dimension called time, which means we need methods that can handle both still frames and their temporal changes across the screens. So there are algorithms that focus on temporal inconsistencies in videos because deepfakes can't quite nail down time coherence yet. Now let's talk about human expressions in deepfakes, because manipulating static images is one thing. Capturing the nuance of human emotion in a video is another ballgame altogether. Advanced AI is now modeling behaviors like walking or smiling and pasting them over someone else's identity with chilling precision. Detecting these manipulations means zeroing in on specific facial regions instead of scanning the whole image. Algorithms compare tiny distortions against vast training sets, capturing diverse facial characteristics. Even minute changes in hair or even eye placement can be dead giveaways when you've got AI on your side. Also, if you remember, we mentioned lighting before. Well, data scientists are onto something there too. They're training AI models to understand natural lighting physics. Because if something looks off with how the light falls on their face or a scene, chances are that it might be a deepfake. So, GANs aren't just cool tech words, they're at the heart of creating hyper-realistic deepfakes that can challenge our trust online. They refine images through adversarial losses until they're virtually indistinguishable from reality. Alright, we've talked a bit about the tech, but sometimes folks, it's not just about the tech. It's about the real people caught in crosshairs of these digital deceptions. Case in point is Indian actress Rashmika Mandanna, whose recent experience with a deepfake video has sent shockwaves through social media and beyond. Imagine waking up one day to find your face plastered on a video you've never shot, doing things you've never done. That's what happened to Rashmika Mandanna when her face was morphed onto an Instagram video of another woman called Zara Patel. It's enough to shock someone, and Rashmika described it as an extremely scary event. And this isn't just a one-off incident, it's a glimpse into a more damaging form of misinformation, as India's information technology minister put it. The alarm was first sounded by journalist Abhishek Kumar from Alt News, who spotted the viral video was a deepfake. He took to X to showcase the original clip and highlight how Rashmika's face had been superimposed as she entered an elevator. The deepfake was so convincing that ordinary social media users could easily mistake it for reality. And in fact, they did. Kumar didn't just stop there at exposing the fake, he called for a legal framework to tackle such cases head-on in the future. And he wasn't alone in this outcry. Bollywood legend Amitabh Bachchan echoed the sentiment, hitting at a strong case for legal action here. Put yourself in Rashmika's shoes, or any young person navigating school or college while trying to fend off such identity theft. It's a chilling thought that has sparked a much needed conversation about urgency and action before more lives are disrupted by this technological abuse. The original subject of the video, Zara Patel, has also expressed distress over being dragged into this deepfake debacle. Her worry for women and girls on social media is palpable, and rightfully so. In our quest for truth in an era of deepfakes, we are turning to AI once again. This time to protect us from the very monsters it helped create. Researchers are training machines to pick up subtle cues like unnatural eye-blinking patterns that were once overlooked by deepfake systems. But here's the twist. As deepfake techs evolve to include realistic blinking, we are forced into an arms race with algorithms learning how different people blink in various situations. These machine learning algorithms are becoming our digital detectives, scrutinizing every flicker of an eyelid and twitch of a muscle for signs of forgery. So, in wrapping up today's episode of WGMI, let's reflect on where we stand with deepfake technology. It's clear that while there are benefits to this innovation, the risk cannot be overstated. Policy making is stepping into the ring. We are taking state-level laws, platform policies, and national legislations, all aiming to penalize those who wield deepfakes with malicious intent. Public awareness campaigns are crucial. They educate us about the ethical boundaries and remind us that sharing a laugh over a harmless meme is one thing, but crossing into identity theft is quite another. It's about collaboration now, and government bodies joining forces with tech companies and society at large to forge techniques that can detect and prevent these from wreaking havoc. As we continue to innovate and regulate in equal measure, cyber law enforcement must involve too, because securing our online space is no longer optional. It's an imperative today. And with that thought-provoking note, we close today's session on WGMI. Remember folks, whether it's keeping tabs on emerging tech or safeguarding our digital identities, together, we are going to make it. Goodbye.